Hello and welcome everybody. This is just a quick video overview of what we're actually doing in the graduate attribute workshops at the University of Pretoria in August 2024. So we have a breakdown of what we plan to do in the larger workshops, and this might differ slightly depending on which group you're in. I'd like to introduce you to the facilitators. This is me, Corin Wolf on the left from Stellenbosch University. We obviously have Lelani Smith from the University of Pretoria, and today we're joined by Teresa Hatting and Bronwyn Schwartz, who are part of National Innovative Engineering Curriculum team. So today we're talking about graduate attributes. What do we actually mean by graduate attributes? What we're hoping to hear from you is that you actually define these as different forms of knowledge, skills, practices, and values. Now, first of all, what we know is that different stakeholders have different interpretations and different requirements. And all of these interpretations and requirements, in terms of what we talk about when we talk about graduate attributes, come to us as lists. Now, the graduate attributes are not meant to be seen as lists. Think about any machine specifications documentation. Yes, there are lists of components, installation processes, but the machine as a whole is greater than the sum of its parts. Now, sorry for the analogy and referring to what we're doing with our students as in machine language, but I think you get the point. What we are interested is in the whole student, the whole context, the whole curriculum. Now, you're going to see a lot of things that some of you may not have encountered, but many of our teams have been working for months already on this whole curriculum redesign, rethinking what it is we've been doing. I just want to take you through some of the holistic models we have been using so that you can see why the focus is on the whole. So we've used a number of models to look at what we're currently doing. The one on the left here is, as you know, our holistic approach, taking account of our students coming into the system, the context in which they are, both the institutional, professional, and social, and the sites of practice to which they're going. We've used the cognitive affective systemic model, and collectively we've identified many challenges at several levels, but I particularly here want to point out the challenges we've identified in the affective domain. Students talking about being overwhelmed, your observations about lack of motivation, many students and your own observations referring to students not seeing the relevance of what they're doing or the industry connection. We've used the Council on Higher Education curriculum principles, and our observations here match our cognitive affective systemic or CAS analysis. We've talked about insufficient or poor foundations and the fact that we need to, it's our mandate in fact, to attend to these. We've talked about the need to expand our idea of literacy practices. These are across academic, quantitative, digital, and disciplinary literacy spaces. And here in the CHE curriculum principles, we see explicit references to enhancement of the curriculum towards the world. Now, in some groups, we've used what you might know as the epistemic plane, it's the knowledge plane, to unpack different kinds of knowledge practices. Now, each of these quadrants represent ways of thinking in different disciplinary and contextual domains. We know from a great deal of research and your own observation that successful problem solvers move around this plane in iterative ways. And we also know from industry and employer feedback that we need to be shifting to the left of that knowledge plane. Industry and employers keep telling us they want more open-ended and complex problem-solving abilities. Lastly, to date, in our processes, we've used what we call the semantic wave to improve how we enable what we call cumulative learning, the connection of theory to practice. Now, some of the teams have already mapped out possible cumulative learning waves. And we've also seen here that we could be doing more to connect to real world examples, to connect to real contexts. So, from all the gap analyses and discussions we've had to date, we know that, if I had to summarize all of your notes, that these are the key things that are standing out as really, really relevant. Students feel overwhelmed and lack motivation. They struggle to connect the parts. They struggle to visualize relations between the parts, and they can't see the relevance. Now, remember when we spoke about the research at the beginning? And all of those instructions coming to us, or all of the graduate attributes coming to us as lists. Well, I was so frustrated with all the changing lists of GAs and the industry, employer, and institutional priorities that I went back to the beginning. Now, the man who coined the term graduate attributes, and in fact who visited South Africa in the early 2000s when we were undergoing several mergers and developing the new higher education qualification sub-framework, is Simon Barry. He described the graduate attributes as a relational model, and that our job is to help our students to develop an attitude or stance towards themselves, an attitude or stance towards knowledge, and an attitude or stance towards the world. Now, developing these three stances enables three key attributes: lifelong learning, scholarship, and global citizenship. Now, the puzzle pieces that we see here in this model are kinds of practices, or call them forms of engagement, that help to relate the self to knowledge and the world. Now, this is the original graduate attribute model. I'm going to show you an example of how we link these various models that I've just taken you through to the graduate attributes that we're going to be having a look at today. Now, today, we're working towards redesigning our engineering curricula. We're asking what we want from our graduates, and we're using the new graduate attribute statements to rethink our curricula. Now, one of my colleagues, Carl Kruger, and many others, have used these models in conjunction in order to better develop graduate attributes in our students. I'm going to take you through a model you've seen already and that I've had at several of our introductions, but just as a reminder. So this is the epistemic plane. It differentiates between, on the vertical axis, kinds of phenomena, the what we're actually talking about, and ways of approaching those phenomena, the what. In other words, the horizontal axis is the how. Now, this gives us 4 different quadrants, or 4 different ways of thinking. And these ways of thinking, in educational terms, we call insights. Now, the top right quadrant is about a strongly bounded or accepted phenomenon, something that we all know is what it is, and it has fixed methods. So all of the fundamental sciences fit into this quadrant, and you could open any textbook on the planet and you'll see that they cover the same kinds of things. Forces are forces, gravity is gravity, momentum is momentum, etc. Now, we call these principled ways of thinking. The bottom right quadrant is about fixed methods, where it doesn't matter what it is you're applying to. So all of the mathematical sciences fit in here, things like the scientific method, etc. And we call these a procedural way of thinking. The top left quadrant is where it doesn't matter what the method is. The thing that we're trying to accomplish is fixed. We all agree that we want X to be achieved. But how we do it is open-ended. How we do it is possible in many, many different ways. And in order to accomplish something, we actually need what we call situational insight. The bottom left quadrant is where it's not clear what the phenomenon is that we're actually addressing, and there isn't a fixed method because the context matters. The people, the stakeholders, in other words, this is the people and places kind of quadrant. Now, what we know about this epistemic plane is that we need to enable our students to think in each of the ways in which these quadrants represent, as well as to move between them. And that's called problem-solving code shifting. Now, from our industrial case studies, there are so many patterns. There's no fixed pattern. But what we know is that we have to enable our students to move, change their ways of thinking. In other words, code shifting. Code shifting is problem solving. Now, my colleague Carl Kruger has used this, and I'll get to an example in a moment, but where he specifically identified the kinds of knowledge in these different quadrants and how to enrich them. So here we have, for those of us who have looked at the knowledge structures, very strongly sequenced forms of knowledge which need to be taught in different ways. In the bottom right-hand quadrant, we have the fixed methods, the standardized procedures. This takes lots more practice and extension into different kinds of problems. In our top left quadrant, we have all of our technology and logic-based sciences. This means there are many different ways in which we can accomplish something using a fundamental logic-based science, let's say, or a technology or an approach, different approaches to a standard kind of problem. And the bottom left quadrant, this is about the world in which we are. Now, again, our job is to enable our students to move around this plane. Here, having mentioned him a number of times already, Carl Kruger took this plane and designed his control systems module using these quadrants. We've taken this one step further. If you look at the Sydney model and you look at Carl Kruger's plan for control systems teaching, let's just take this one at a time. So he starts in the real world, that bottom left-hand quadrant, and he asks his students for examples of where they think we have a control system kind of context. Okay, what does control theory actually look like in the real world? Now, the practice he's drawing on there is, well, ethical, professional, social understandings of control. By stretching his students to think about where you see control systems problems in the real world, he's actually developing GA7, impact on and practices in society. He then moves them into what are the different opportunities for applying control theory. So this stretches the practice into research and inquiry. He can ask his students in the class to use ChatGPT or use the internet or use each other's knowledge and look for different kinds of control theory opportunities. Now, the GA he's developing there is investigation, but drawing on the collective. They're all going out and conducting some kind of research inquiry. It's not the focus of his module, but he's already built it in. Then he moves into the purest quadrant, where they need to understand the principles of deriving a mathematical model of the system. Now the practice here is information literacy. They need to decode and work out, based on their prior knowledge and on the knowledge that he's teaching them, what kinds of practices are appropriate here. Then he tasks them with designing and implementing a very simple step in designing a controller in a virtual practical. Here, they have to apply their knowledge. There's the GA that we're developing, and move into the design phase. That's number 3, and use certain tools and techniques. But the practice here is intellectual autonomy. They have to work on their own and practice basically self-regulated learning. Then he moves them into visualizing this response in a virtual prac. Now this takes them into the world again, looking at what does this visualization that they've generated in a virtual prac look like in the real world? So here they could be looking at videos, for example, of, I don't know, SpaceX landing or operating a drone, and so on. So what I hope that you've seen from this example is that there's a relationship between all these models, and there's a way in which we can move our students' thinking around the knowledge practice plane, the epistemic plane, in a way that enables them to be developing the graduate attributes that are not even the focus necessarily of the module itself. In a different study, we've taken all of those graduate attributes, the key names, and looked at where's the home base of those different graduate attributes. Now, it's important to note that each of these attributes involves all of the ways of thinking, but that you can start at a specific point and develop that particular attribute in a cyclical or iterative or code-shifting manner. I'm going to park that for now, and I'm going to hand you over to my colleagues who will take us through the new GAs.